So in this question, we've been asked to prove that for all values of n that are elements of a set of integers where n is greater than or equal to 0, that the sum of this series can be written in terms of n that we have here, where a, b, and c are integers to be found. So we're going to use the method of differences with this question. So the first thing that we need to do is to write this using partial fractions. So we'll say that this is equal to a over r plus 1 plus b over r plus 2 plus c over r plus 3. And then we'll multiply both sides by this denominator. You can see here that all the terms will cancel. This r plus 1 will cancel with this one. The r plus 2 will cancel with this one. And the r plus 3 will cancel with this one. So what we're left with is 1 is equal to a lots of r plus 2 and r plus 3 plus b lots of r plus 1 and r plus 3 plus c lots of r plus 1 and r plus 2. Then to work out the values of a, b, and c, we need to make each of these brackets equal 0. So if we let r to begin with equal -1, then that will make this one equal 0, and it will make the c term equal 0. So we're left with 1 will equal a, -1 plus 2 is just 1, and -1 plus 3 is 2. So a will equal 1/2. If we let r equal -2, the a terms will cancel, the c terms will cancel, so we've got 1 will equal -1 and +1, so minus b, so b will equal -1. Then if we let r equal -3, the a terms will cancel, the b terms will cancel, so we've got 1 will equal c lots of -2 multiplied by -1, so c will equal, again, 1/2. And now we can substitute each of these back into our partial fractions. So at this point, the easiest thing to do is to pull out this half in front of all three fractions. So we get 1/2, then we get 1 over r plus 1, minus this numerator becomes a 2, because when you multiply it by the half, we get the 1, and then we get 1 over r plus 3. Okay? And now we can split this up, ready to find which terms will eliminate. So if we substitute in r equals 0, we get 1 over 0 plus 1, so just 1, -2 over 0 plus 2, which gives us -1, then we get 1 over 3. If we substitute in r equals 1, we get 1 over 2 here, -2 over 3, and 1 over 4. We'll do a few more. So we get 1 over 3, minus 2 over 4, and 1 over 5. When r equals 3, we get 1 over 4, minus 2 over 5, and 1 over 6. Now if we substitute in when r equals n minus 1, we'll replace this r with n minus 1. The -1 and +1 will cancel, so we get 1 over n. N minus 1 plus 2 will give us -2 over n plus 1, and n minus 1 plus 3. This will become 1 over n plus 2. Then finally, we'll substitute in r equals n. This becomes 1 over n plus 1, minus 2 over n plus 2, and 1 over n plus 3. So now we need to identify which terms will cancel. Well, you can see this one will go with this -1. Then we've got the 1/3 plus the 1/3 minus 2/3. So these will cancel. We've got 1/4 plus another quarter take away 2/4, these will cancel. And then the same here. This will be the term after 1/4. And then this term will cancel with this term, which will be the term 1 above this one. So these will cancel as well. And then you can see we've got positive 1/n plus 2 minus 2/n plus 2. So these will simplify to make minus 1/n plus 2. And then we need to include this term and this one. And this one as well. So then this will simplify to make 1/2 minus 1/n plus 2 plus 1/n plus 3. Now all we need to do is use equivalent fractions to add these three together. I'll begin with this denominator. So we've got 1/2 minus 2/n plus 2 plus 2/2 lots of n plus 3. And that should be a 2 here as well. Then we'll move on to this denominator, n plus 2. And then we'll do the n plus 3. And now we've got a common denominator, we can write it as one fraction. Sorry, actually, this should have been a negative here. So I'll just change that. And we've got negative 2 lots of n plus 3 plus 2 lots of n plus 2 all over our common denominator. So now we need to simplify our numerator. We'll get n squared plus 5n plus 6 minus the 2n minus the 6 plus the 2n plus 4 over our denominator. And then we can simplify our numerator. We've got n squared. This one will cancel with this one. And a positive 6 will cancel with a negative 6. So we get plus 5n plus 4 over our denominator. And then you can see we can factorize this numerator. So we get n plus 1 multiplied by n plus 4 all over 2 lots of n plus 2 multiplied by n plus 3. But we need to remember that what we did at the start was we pulled out this half. So we've just simplified this, but now we need to multiply it by a half. And this becomes n plus 1, n plus 4. We double this 2 to get 4. So in terms of our initial question, we need to work out a, b, and c. Well, a will equal 1, b will equal 4, and c will be equal to 4 as well. Okay?